All right, Science 30s. I think this is recording now. Mr. Riley here, and just a quick video on doing wave equation. And so we talked about EMR. EMR travels in waves. When we look at a wave, there's a couple different things that we can measure about the wave. We're going to use those in our next formula here. So this is page 3 in your data booklet. The formula that we're going to look at here is this one. C equals F lambda. So we got to think back, what are all of those different variables? So C is the speed of EMR, otherwise known as the speed of light. It's constant for all types of EMR. So whether you're a radio wave or a gamma wave, you are traveling in a vacuum at 3.00 times 10 to the 8 meters per second, pretty fast. The frequency is how many waves pass a point every second. And we measure that in something called hertz. And the wavelength, this weird symbol right here is called lambda. And it is the symbol for wavelength, and wavelength is something we measure in meters. So when we're looking at a wave, so let's say I have a short wave, and I compare it to a longer wave. One of the relationships we want to look at here is if I have a short wavelength, more of those waves are going to pass a point every second. So short waves have high frequency. Okay, so if the wavelength goes up, the frequency goes down. So that's where the next example comes in. So the wavelength is going up. So we're increasing the length of the wave. And in that case, less waves are going to pass a point every second, and we're going to get a lower frequency. Okay, so short waves have high frequency. Long waves have low frequency. We want to look briefly at all the different types of waves. And how to read this scale right here. So you see the top of the scale is frequency in hertz. So we're going from 10 to the 3 on this side to 10 to the 23 on this side. So that means every second, 10 to the 23rd power of waves are going to be hitting you. That's a lot. But with waves on this end that are going to be lower frequency, only 10 to the 3 or 1,000 waves every second are hitting you. I mean, it still sounds like a lot, but it's not nearly as much as 10 to the 23. And when we look at the bottom of the scale here, we see the wavelength. And the wavelength actually, as you go from left to right, decreases. So I'm going from 10 to the 4, 10,000 meters long of a wave, down to 10 to the negative 14, which is like on the atomic scale, so tiny. So waves that have a really long wave, these are all of sort of the longer wave EMR that we would look at. So going from the longest radio, we have some special types of radio waves we use to transmit television signals, communications. We use them to heat our food. This is also 5G. Maybe you guys are into some of those 5G conspiracy theories online. And then we go all the way up to visible light. So this is the only piece of EMR that we can actually see with our eyes. All of this stuff is called ionizing. That means it doesn't mess with your your cells. It can't cause cancer. So any type, unless it's a super high intensity or super high amplitude wave, on this side of the spectrum, it won't cause cancer. Generally won't hurt you. But when you get to the other side, so anything that's from ultraviolet and higher frequency, these are called ionizing, and these types of things can actually knock things around, knock electrons around in your DNA, cause mutations, and can cause cancer. And so that's not good. And I mean, we actually use gamma radiation for cancer treatment because it's so good at killing cells. But That's sort of the rough of that. So now let's look at the calculation. Looking at my wave formula, let's look at this problem. Okay, so CBC radio broadcasts radio waves at 93.9 megahertz. So oftentimes, since there's such a wide range of different frequencies, we don't want to say like, 9 gazillion hertz. So we're going to use the metric system conversion, and we're going to convert to a different unit. So if we look in our data booklet, we're going to see that this is times 10 to the 6. When we get to the mega scale, it's 1 million of something. And so let's take a look at it. So that's my wavelength. So CBC Radio 1 broadcast at 93.9 megahertz. Calculate the wavelength of the radio waves. So I want to know the wavelength. Okay, that's my symbol for wavelength, that lambda. My frequency is 93.9 megahertz. So I'm going to do a little trick here. 93.9 megahertz. I'm just going to take my number here, and I'm going to say 93.9 times 10 to the 6 hertz. And again, that's on page 1 or 2 of your data booklet. And so I'm not going to mess around with this decimal over here. I'm just going to put that times 10 to the whatever on the end of this. And it's just a little bit of a shortcut. So for when I'm calculating, C is a constant for us. That's 3.00 times 10 to the 8 meters per second. So when I look at my wave formula, it's C equals F lambda. How many waves multiplied by, how many waves per second multiplied by the length of the wave is going to give us the speed. Now the speed is always constant, so we need to manipulate this formula for lambda. So I'm going to divide both sides by F, and I'm going to get a new formula. Lambda equals C over F, and I expect you guys to be able to manipulate a 3-variable equation. So I'm going to take 3.00 times 10 to the 8 meters per second, and I'm going to divide that by 10 to the 6 hertz. And I mean, we could mess around with units, but we're not going to go crazy here. So let's just look at this, and we'll do 3.00 times 10 to the 8 divided by 93.9 times 10 to the 6. And if you're not using the E function, you guys, you have to use brackets. Okay, be careful with that. And I'm going to get this. Okay, so this is 3.19. Do I got a round? Yeah, 3.194. So 3.19 meters. And so that's a radio wave, and I guess maybe let's just go back up and take a look here. 3.19 meters. I mean, that's going to put us in, somewhere in this area right here, right? Okay, so this would be between 1 meter and 100 meters. So taking a look at that, and that fits perfectly. Radio wave right here. I mean, maybe a television wave, but that's one way to check your work. So do a couple of the practice questions, and let me know if you have any problems. Okay, take it easy, you guys.